The position vector of points A, B, C are A, B, and C respectively. Point C divides A in the ratio 5 to -2. Express C in terms of A and B. So when it is dividing like this one is external. It is external division. So let's try to sketch the diagram. So we have A, point C is dividing AB externally. So we have B and C. So we have been told this is A, B, and C. This is O. So from A to C, from here to here, it is 5 units. From here to here, it is 2 units. That's why it is given -2, because it is 2 units. It is going and then coming back. That is, if this is positive, this coming back is negative. That's why we have -2, and that is external division. That is external division. So remember the ratio theorem. If I say this one is our M, and then this one is going to be my N. This one is going to be my N, because from here up to here is M, from here up to here is N. So if I want now OC in terms of B and A, in terms of express C in terms of D, it is simple. You use this ratio theorem. So OC is equal to N over the total N plus M times the opposite upper ndio boundary. So opposite ya N ni hapa na opposite ya M ni hapa, itakuwa B. 5 itakuwa hapa. So we will have M over M plus N, B plus N over M plus N, A. So now let's substitute the numbers because we have M and N. This one will be M, our M is 5, over M plus M. M ni 5, N ni, so 5 plus -2, the answer is 3. B plus -2 over 3A. So this is the same as, so C or point C or OC is going to be negative. We can start at 5 B over 3 minus 2 over 3A. So this is the vector, position vector of C, of OC in terms of B and C. Let me do this method. Let me use a different method. Maybe the one you are used to. A, B, C, hapa C, B, A, O. So we know that OC is equal to OC is equal to OA, OA plus AC plus AC. From here up to here is 5. From here up to here is 2. So it means from here up to here is 3. From here up to here is 2. From here up to here is 5 units. From here up to here is 2 units. Therefore, here is 3 units. Here 2 units to make a total of 5. That is what we know. Therefore, we know OA. So OA is in vector A plus AC. But AC ni nini? That is now where you need to understand. Remember, the total, this was negative. Nataka ujue hiyo. Remember, hii ilikuwa minus 2. It is for long as it is external, this is negative. So the total m plus n here total is not going to be 5. From this plus this total sio 5. Kutoka mpaka hapa ni 5 ndio. Lakini total haitakuwa 5 kwa nini? Kwa sababu ni 5 plus minus 2. So from the total here is 3 minus 2 itakuwa 3. So from A to C is 5 over the total, which is 3. Understand that? So meaning AC is 5 plus 5 over 3 AB. So AC is 5 over this AB. Now A plus 5 over 3, you need to get AB. How do you get AB? AB is equal to AO OB, which is B minus A. B minus A. So A plus 5 over 3B minus 5 over 3A. Like terms together. So A minus this one, A minus 5 over 3A plus 5 over 3B, liking terms together. This one is going to be minus 2 over 3A plus 5 over 3B. And this one, so OC is equal to, tukianza na positive itakuwa 5 over 3B minus 2 over 3A. As we do more examples, you will be able to see what we are saying. The coordinates of A, this, and B, this one. A point B divides AB externally in the ratio 7 to 3. Determine the coordinates of B. Sketch. So this is B, this is B, and this is A. We have the coordinates of A. This is O. So from A to B, is 7 units. From P to here is 3 units. That is minus 3, because this one means this one is the same as, actually you need to understand that this one is the same as AP to PB is equal to 7 minus 3. Hii inamaanisha hivi. That's what it means. So it means here is 3 units, here is 4 units. That's why from here up to here is 7. Now to get AP is the total from here up to here, which is 7 over 4, because the total is 4. Why is the total 4? The total is 7 plus minus 3, which is 7 minus 3, and the total is 4. So M plus N is equal to 4. Remember that. Remember that. So it means that AP is exactly equal to 7 over 4 AB. Remember that. So let's look at this one. We can now use the ratio theorem. If I give this one M, I give this one N, then we know how so what we want is to find the coordinates of B. We are looking for the coordinates of B, X, Y, Z. That's what we don't have. We have the coordinates for B. Here they are. The coordinates of A, here they are. 2, 8, 3. -4, -5, -8, 5. -8, -5. Those are the coordinates. So let's straight away to the working. But we know we can go straight and get P. P, we can get it straight. But I want to go is the way that you understand. How do we get OB? OB, using ratio theorem, OB is equal to, using the ratios in 4 over the total 7. 4 over the total 7, which is 4 over 7. So we are using, because we want OB, 4 over 7 B. OP plus 3 over sort of 7. This opposite ya 3 ni OA. Tunaelewana hapo? Therefore, now but we have the coordinates, sir. We have OP already, ndio hii. So this is, I think this is the simpler way of doing it. Now this one ilikuwa -4, -8, -5 is equal to 4 over 7. OP, we are looking for OP, which is X, Y, Z, plus 3 over 7 OA, which is 2, 8, 3. Yes, so from here now, you can multiply and bring this one this side. You can do whichever way you want. So first, let's multiply this one. So it means -4 minus 8 minus 5 is equal to 4 over 7x, 4 over 7y, 4 over 7z, which is equal to, let us multiply this times this, 3 itakuwa 6 over 7, the first one, itakuwa 6 over 7, 3 over 7 times 8 itakuwa 24 over 7, 24 over 7, 3 over 4 times itakuwa 9 over 7. Sorry, plus. Inafaa kuwa plus. So inamaanisha this is equal to this plus this. So we can solve now each individually. So we'll say -4 ya kwanza is equal to 4 over 7x plus 6 over 7. Now from there you like terms together to get the values of x. You bring this one here, itakuwa minus. -4 minus 6 over 7 is equal to 4 over 7x. Use your calculator. You will find that this one is going to be, finally itakuletea, you multiply times 7 times the reciprocal of this. We want x. So if we want x here, what you do, you multiply both sides by the reciprocal of 7. Ukiminus itakuwa minus 34 over 7. Ukitumia calculator hapa itakupea minus 34 over 7, which is equal to 4 over 7x. So multiply times the reciprocal, 7 over 4 both sides, 7 over 4. So negative 34 over 7 times 4 over 7 times 7 over 4. That is the value of x. So x utapata ni negative 8.5. unafanya the same for y, ambayo utapata is equal to negative 20. Utafanya the same for z. Z utachukua negative 5. Negative 5 is equal to 4 over 7z plus 9 over 7. Like terms together, take this to the other side. Like this to the other side. Ukichukua hii side itakuwa minus 5 minus 9 over 7 is equal to 4 over 7z. Ukifanya hii like term together, utapata kwamba itakuwa negative 44 over 7 is equal to 4 over 7z. Multiply the reciprocal here, we find that z is equal to minus 44 over 7 times 7 over 4. Utapata z ni negative 11. So utapata kwamba p itakuwa ni 8.5 minus 8.5 negative 20 negative 11. That is the coordinate of p. There is a way you can do it again direct. If you have understood hii venye nilikuwa na explain hapa, it is even more direct than this one. Maybe let me do it that way so that I can do it directly to get to use this method too. You need to understand that from A to B is 7, A to P is 7, and P to B is negative 3 because it is external. And if that is the case, this one is 4. But from here up to here is 7. So if you understand like that, then we will give from here up to here is m, this negative is n. That's how we are going to get our ratio now. So we are going to use the ratio theorem direct to get OP in terms of B. OP will be m over m plus n OB plus n over n plus m OA. So OP, which is XYZ, is equal to m is 7 over total, which is 4. OB ni OB tulikuwa tumepata ngapi? OB, that is B, that is 4 minus 4 minus 8 minus 5 plus n, which is minus 3 over the total 4 into A, which is 283. So this one will give us OP directly. So this one is the same as this times that, you will get negative 28 over 4. This times this is negative 56 over 4. Actually, this cancels out. So let me cancel this so that I cancel. So 4 will cancel out, so we'll have negative 7. This negative 7. 7 over 4 times negative 8, we will have negative 14 because it is 7 over 4 times negative 8, negative 2, negative 14, and this one will be negative 35 over 4. That one does not cancel out. This one plus this one goes there, that is itakuwa negative 3 over 2. This one will go there twice, negative 6. This one will be negative 9 over 12 over 4. So now we can add and see. So negative 7 plus negative 2 over 3, the answer is negative 8.5. Negative 14, negative 6, the answer is negative 20. Now you press your calculator. Negative 35 over 4 minus 9 over 4, negative 9 over 4. You find that it is 11, negative 11. So it is actually the same like what we got here. So you can choose to do this way or this way, the one you want. For external, you need to be very careful. In the figure below, OA is vector A, OB is vector B, OB is vector B, OC is 3OB, so OC is 3OB. So if OB is a B, then from here up to here is going to be 3B. OC is 3B. Be aware of that. Express AB and C in terms of A and A, in terms of C and B. B, given that AM is this and A is, so express OM and ON in terms of AB. C, show that OM and ON are collinear. So let's start by expressing AB and AC in terms of A and B. So AB is equal to AB is equal to AP. We can get AB, or we are looking for AB, so it is AO plus OB. AO plus OB. So that is vector. Remember, this vector is going OA. Whenever you are coming OA, the vector becomes negative. So AO is negative A plus OB. OB is B. This is the same as you start with a positive B minus A. That is vector. Now vector, next one is vector AC. So AC, how do we get AC? AC is equal to AO OC. AO plus OC. But we know that AO is equal to minus A plus OC. OC is 3B plus 3B vector, 3 vector B, and this is the same as you can start with a positive 3B minus A, like that. So we are done with number A. So part B, we are given that AM is 3AB. So AM, that's where we start. AM is equal to 3 over 4 AB. But we have AB. This is the same as 3 over 4 AB, and our AB is B minus A. So this is the same as 3 over 4B minus 3 over 4A. 3 over 4A. And AN is equal to AN is it yeah, AN is equal to a half AC, which is equal to a half AC. We have AC, which is 3B minus A, meaning that AC meaning that an is equal to a half. A half times 3 itakuwa 3 over 2b minus 1 over 2a. That is our an. You multiply this times everything inside. Very nice. So once we have expressed it that way, we need now to express OM and ON. Now, how do we get ON? So let's go back here. OM is equal to a certain scalar of ON, because ON, so we can first get ON. OM is equal to OM is equal to OA plus AM. Yes, but we have OA, which is A, plus AM, but we have AM here. This is our AM. So plus AM, which is 3 over 4b minus 3 over 4a, meaning that OM is equal to 3 minus 3 over 4a itakuwa 1 over 4. Itakuwa 1 over 4a plus 3 over 4b. Hiyo ni OM. Now tunataka ON. ON. How do we get ON? ON is equal to OAAN. That's one way of getting that. There's another way, but we can use that one. ON is equal to OA plus AN. But remember, we have AN here. So we go this way direction because we have already obtained AN. That's why I'm using AN, because we want to express ON in terms of B and A, and we have AN. This one is ON, which is A plus AN, and our AN is 3 over 2b minus 1 over 2 vector A. Right? So we like terms together. 1a minus half a is going to be a half a plus 3 over 2b, and that is our ON. We have now answered the question, express ON and OM in terms of A and B. We have done that, and I hope you are following. So now next is to show that number C, to show that OM and ON are collinear. So for them to be collinear, I have explained how to show for collinearity, is that we must show that OM, ON are collinear. We must show that you can express one in terms of the other, that it means they are parallel, and they are sharing a point, and you can see that they are sharing point O. That one is obvious. So first, kibarua ni kuonyesha that they are parallel. Now that's what we want to show. Let's show now. We are part C. We show that they are. So we have OM tunayo ni 3 over 4b plus 1 over 4a, which is equal to, we can now introduce a constant k, which would equal to k ON. It must you must express one in terms of the other, and then you are able, if it is possible to express one of them, you can say, si lazima uweke k hapo, you can say k o m is equal to o n, or this way, o m is equal to k o, it must be expressed in terms of the other. So I have decided to express that OM is equal to KON. So let us use this one. But you can use either. So 3 over 4 vector B plus 1 over 4 vector A is equal to KON. Our ON is here. You write it. I have A plus 3 over 2B. Now 3 over 4 vector B plus 1 over 4 A is equal, let us open this one, we will have a half AK plus 3 over 2BK. So ukifika hapa, you compare the coefficients of K where we have vector A, so vector this one and this one are the same, and the one with B, this one and this one are the same. So we compare those ones that have the same vector, B or A. So that's why we are going to say now that 3 over 4B, when we ignore B, will be equal to 3 over 2K. Now that one is going to give us the value of K. So this one will be 3 over 4 is equal to the reciprocal hapa itakuwa 3 over 2 times 3 over 2K times reciprocal 2 over 3. So K is equal to 2 over 3 times 3 over 4. So K is equal to a half. Even if you use this one, the answer should be the same. Let us use this one. 1 over 4 is equal to 1 over 2K. To get K, you multiply both sides by the reciprocal so that we remain with K. Reciprocal of this 2 over 1. So 2 over 4 is equal to K, and K is equal to a half. So it means that OM is equal to a half ON. It means that they are parallel. So we have shown that OM and ON are parallel. Now the final thing is to say that O is the common point, hence they are collinear. They are collinear. Hence they are collinear. So to show collinearity, you need to show that they are parallel. You can express one in terms of the other, and they are sharing a given point. In the figure below, OAB is a triangle. OAB is a triangle in which M divides OA in the ratio 2 to 3. So it means this is 2 and this is 3. It means that way. Again, and N, this is N, divides OB in the ratio 4 to 1. So ON divides OB in the ratio 4 to 1. So this is 4 and this is 1. That is the ratio. AN and meets at X. So they meet at X. Then express the following in terms. So we have been told that OA is vector A, OB is vector B. Express AN in terms of A and B. So let's start with A. Part A, to express this, we can even express them here. AN is equal to AO plus ON. AN is equal to AO plus ON. Now remember, when this is the arrow is going this way, because OA we are going this way, OB, this is the arrow. Therefore it means this way A is positive, coming this way A is negative. Remember that. So this is the same as negative A, because we are coming negative, the opposite of A, plus ON. ON is 4 over the total 5. 4 plus 1 is 5. B. And that is OAN. BM. So BM, how do you get BM? BM is equal to BOOM is equal to BO plus OM. BO plus OM. Remember, these are the vectors. It is important you put an arrow like that, so it is not a must, like that, showing that we are going that direction. So this one means BO, we are going against B, therefore it is going to be minus B plus OM. OM is 2 over the total 5, vector A. Then AB is equal to BO plus OA, right? Yeah. AB, we are starting with BM. Whoa, sorry. AB is equal to AO plus OB, which is minus A plus B, and this one is equal to B minus A. So tushamaliza kuexpress all of those in terms of A and B. So let's go straight to part B, where our 6 marks is. We have been given that AX is SAN and B, so we can simply start by getting AX. We can simplify starting by getting AX. So AX is equal to S into AN, but we have AN, which is 4 over 5 vector B minus A. So meaning this one is AX itakuwa ni 4 over 5 vector BS minus AS. We can also express BX because we need it. This is TBM, which is the same as T into BM. Our BM is 2 over 5A minus B. So BX is equal to 2 over 5 vector AT minus BT. That is vector PX. That is vector BX. Now that one is important because now we want to express OX in 2 ways. So OX is equal to, so OX, we have now this here, OX. We have OX there that we want to express in two ways. I don't know why it is fading. So OX can be OA AX. Can it be OX? OX is equal to OA plus AX. You make sure you go to the direction that contains these values we have obtained here, AX. We need to use that. So this one is OA. OA we know is A plus AX, but we have AX here, which is 5 or 4 over 5 BS minus AS. That's one way of expressing OX. We can simply bring this one together. This one will be A, like terms, minus AS plus 4 over 5 BS. Actually, you should know this one is, let us make it even simpler. We will put A outside, and then 1 minus S plus 4 over 5 BS. That one becomes simple, and it's going to help us to get now. Another way, the way OX also, we can also say OX is equal to OB BX. OB plus BX. OB plus BX. But we know OB is B plus BX. We have our BX here. BX is equal to 2 over 5 AT minus BT. So bring this one on this side so that we can have B minus BT plus 2 over 5 AT, so that we can have this one as B into 1 minus T plus 2 over 5 AT. Now, since this OX and this OX are the same, we are going to equate them and say that they are equal. They are equal because they are the same. Whether you use a different route, you are going to obtain the same results. So we are going to equate them here and say that A minus A into 1 minus S plus 4 over 5 BS is equal to B 1 minus T plus 2 over 5 vector A T. Now, those that have the same vector, they are equal. This and this, we equate them. This and this one, we equate them because they have the same vector B and B. That is what we do. So, and once you equate them, you ignore mambo ya A. So this one is to show us that these are like. So it means now we ignore A. So 1 minus S is equal to 2 over 5T. That is our equation 1. And 4 over 5S, you ignore B, is equal to 1 minus T. And that is our equation 2. Now we solve equation 1 and equation 2 to get the value of T and the value of. You can try to use substitution. Let me do substitution. I will make S the subject for the equation 1. I will say minus S is equal to 2 over 5T minus 1. Hii ikikuja pande inakuwa plus minus. I want to divide by -1 for each case, so I have s is equal to minus 2 over 5t plus 1. Hii negative itachange sign ya pande hii yote. Sasa ninachukua hii s kwa equation 2 na substitute, napata the value of whatever I want t. So I will substitute here, we say 4 over 5s. Instead of s, I will say 1 minus 2 over 5t. Hii ni kama, this is the same as 1 minus 2 over 5t is the same. Will be equal to 1 minus t. So open bracket, we will have 4 over 5 minus this times that, hakuna yenye na cancel, so itakuwa 8 over 25t is equal to 1 minus t. Like terms together, you bring this there and this one here. So 4 over 5 minus 1 is equal to minus t plus 8 over 25t. So using your calculator, you will find that this one is going to be -1 over 5 is equal to -1t minus this one is going to be negative 17 over 25. And this is t. So to get t, we multiply by the reciprocal of t so that we both sides. So we are going to multiply the reciprocal. The reciprocal will be 25 over 17 times -1 over 5, and negative will go, and this one will remain t. So 5 here once, here 5. So t is equal to 5 over 17. That is our t. Our t is 5 over 17. So to get s, remember we said that s is equal to 1 minus 2 over 5t. Now we have t. The s will be equal to 1 minus 2 over 5 times t, and our t is 5 over 17. So this is 1 minus 2 over 17, because 5 and 5 will cancel out. So s is equal to 17. This is 17 over 17 minus 2 over 17. S is equal to 15 over 17. Now you have gotten your values of x, of s and t, and that is your business. That was the business of getting the value of s and t. So I hope you have followed. Thank you. Ratio theorem. Very important to know the ratio theorem. It's very, very critical to know the ratio theorem. So I want to sketch a diagram here. We have O, we have A, we have B. This is vector A, and this is vector B. And if this is C, this is vector C. So A has got AC as a ratio. If we take AC to be ratio M and CB to be ratio N, then the ratio theorem says that we can get OC. So OC from the ratio theorem, OC using the ratio theorem would be equal to M N divided by the total ratio, which is N plus m. Now you see this line OC divides AB into a certain ratio, which is mn, right? So I want to put a demarcation here. So this is, let me use a different like this up to here. Now you see, I have said OC is equal to n. Whenever you use n, the opposite of n is this vector, the opposite of n. So OC will be n over the total vector A yenye iko kwa opposite, which is 4. Next, m plus is going to be plus m over n plus m over what? And then times which vector? Times the vector which is in the opposite. Now let us look. This is m. The vector that is the opposite of m. The opposite of m is this direction here. Unaangalia hii line. Hii ndio boundary. Si unaona hii ndio boundary. Kwa hivyo opposite ya m ni hii side. Opposite ya n ni hii side. So this one will be vector A. Vector A. Vector B, sorry. So, and this is what we call the ratio theorem. So ratio theorem sio kitu ingine inakustua, ni kuunderstand kwamba if we have a vector position like O, A, B, C like this, then to get the vectors of O, C directly without struggling to go O, A, C is simply you write the provided ratios in this manner. So I think when I am going to do, let me do a straight example so that you can be able to see. Find OB in the figure below. This is vector A, B, vector C, vector B, and this is vector A. Here is 2 to 3. So OB, you can get OB using a wrong process where OB is equal to OA plus AB, meaning that A plus 2 over 5. Now, the ratio here is, this is M and this is N. And now this time round, we have the numbers there. So this is 2 over 3. So the total M, 2 of AB. Now 2 is M and the total is 2 plus 3. That's why nimeweka 5. So this is the long way of getting that. Inamaanisha lazima utakuwa umepata AC, not AB. Yeah, AB. But this one will be AB itakuwa 2 over 5 AC. So that one is the wrong. Now using ratio theorem, I can get OB directly as this. OB using the ratio theorem is equal to 3, this N, over the total, which is M plus N, which is 5. That is 2 plus 3. And then the opposite, hii ndio demarcation hapa. The opposite, so 3 hii opposite yake ni hii. Itakuwa A plus 2 over total 5. Opposite ya 2 C line ndio hii, ni hii side. Sawa, which is going to be C. And that is the ratio theorem. Now, let me do examples that involves the ratio theorem and involve external division of lines. External division of lines. Maybe I start with one example for internal division of a line. The coordinates of A B and C B is not given. B is not given, so B is XY given that AB to BC is equal to 2 to 3. Find the coordinates of B. Find B. So you can sketch your diagram so that you can be able to see. So we have A, we have B, and we have C. This one can even be origin. So this one is 2, 3. This one is 8, 7. We are looking for this, but we have been given the ratio. This is 2, 2, 3. From the ratio theorem, we know that if I take this one to be C and take this one to be A and this one to be B, then we know that OB is equal to, using the ratio theorem, will be equal to, OB will be equal to 2 over the total, 2 over 5. Remember, I'm starting with 2 over the total 5 of the opposite. Opposite yake ni C plus 3, opposite ya 3 ni A. 3 over total, which is 5A. But now we have been given the values of A. OB will be equal to 2 over 5 C, and our C is 8, 7, plus 3 over 5 A, and our A is 2, 3. So meaning the coordinates of B will be equal to 2